Alrighty, welcome, children. Hope you had a lovely weekend with some phenomenal, although warm weather this weekend. I'm actually out on my Muskoka room right now, and it is raining. So if you hear something in the background, that's what it is. So we started to talk about compound interest already. We looked at a couple of different formulas that we could use for compound interest. There is also something called simple interest that I'm not even going to bother introducing because the reality is simple interest has virtually no role in the modern world. So even though it's on our curriculum, I'm not going to bother with it. So compound interest. We're going to talk about, compound interest. We'll just go with that. And in particular, today we're going to focus on something called present value. So the formulas that we have looked at, and they're interchangeable, are A equals P bracket 1 plus I to the exponent N. Okay, so that's one version. Or PV, excuse me, not PV. It is going to be FV equals PV bracket 1 plus I to the N. And so, the reality is that P here stands for principal, and didn't choose the color. And then the PV stands for present value. But the reality is they represent the same quantity. And then similarly, the A stands for amount or annuity or lots of different things. Not annuity, but amount, or future value. So what it's worth in the end. So present value is how much is it worth at the beginning of the timeline. FV is future value, what's it worth at the end of the timeline, and the same goes here. So they're interchangeable, and it's, whichever one you want to use. Now, I'm going to put up an example just so you can try it, and I really like you to pause the video, give it a whirl to make sure that you're on board with where we're at, because we're going to progress on from here. So Bert invested, $7,500 at 10% interest per annum, compounded quarterly for a period of about 20 years. Multiple parts. First part, what is the final investment worth? And the second part is how much interest in total did he earn? Okay, so how much interest in total did he earn? All right, so easy peasy. So I'm going to go with the A. So we have A equals P bracket 1 plus I to the exponent N. I'm going to list out each of those variables and fill in the chunks that I know. So A is the final amount, and it lays out right there. What's the final investment worth? Clearly, I haven't been given that, so we don't know what that is. P is principal. So the principal is $7,500. Principal is the lump sum that we put away at the beginning of an investment. Okay. I is the interest per compounding period as a decimal. So I identify the interest rate. So I'm going to go grab a different color here. So here's my interest rate. It says 10%. Oh crap. 10% per annum. But it's 10% per annum. And then here it says compounded quarterly. Quarterly means 4 times per year. Right? So we're going to take our interest rate, which is 10%. Go back to black. So 10%. And we're going to divide it by 4, because that's how many times it compounds per year. And so that would be 2.5. And it is. It's 2.5%. But I want it as a decimal. So then I'm going to divide it by 100. right? So you can put that in your calculator if you need to, but it's 0.025, okay? And then N is the total number of compounding periods. So obviously the years piece comes into play here. It's 20 years that we're doing this for, but there's more than one compounding period per year. In fact, there are 4 of them per year. So we're going to take 20 and times 4, which is going to be 80. I will remind again that whatever you divide by here, right? So we divided by 4 here. It's the same number that we multiply by here. Always going to be the same number. Okay, so we go back and we substitute those values in. So we're going to have A equals P, which is 7,500, bracket 1 plus I. So you could say 1 plus 0.025, but the reality is it's just going to be 1.025. And then N is 80. Okay, now that's well beyond what I'm able to kind of figure out in my head. So I got to grab a calculator. I should have had that open earlier, but I don't. All right, so we're going to go ahead and we're going to dump that into our calculator. So 7,500 bracket 1.025 to the exponent 80. So if Bert put $7,500 away for 20 years at 10% per annum compounded quarterly, he'd end up with $54,071.76. So 54,071, and I think it was 76 cents. So that's an enormous amount of money given he only put 7,500 away. Now, the reality is 10% these days is not a terribly realistic interest rate. It's feasible. Some investments reach that capability, but it's certainly not, you're not going to put it in the bank account and get that. And you're not going to put it in a bond and get that. That would rely on some stock market trading or some real estate trading or something like that. But, 10% is not unheard of. It's just not very common. Okay. So that's review. We're all good on that. That's the same stuff we were doing last week. Let us step ahead and we're going to look at a similar kind of thing. So imagine that we did the following. Imagine that we said, in 5 years, Emma is going to need $7,000 to pay for a new iPhone because they're stupid expensive. Now, so in 5 years, Emma's going to need $7,000 to pay for a new iPhone. She can earn, I don't know, how about she can earn 8% per annum, and I'm going to go easy, compounded annually. How much must she invest now to end up with $7,000 in 5 years? Now, I just realized as I'm writing this down, I skipped one piece of this question. So I'm going to zip back. I apologize. Question 2 was, how much interest in total did Bert earn? Well, interest is always going to be what the final amount is, not equals, minus what the starting amount was. So minus 7,500. So it's that $54,071.76 minus the $7,500, right? Because the 7,500 of that 54,000 was money that Bert put there, so that wasn't interest. So I'm just going to come back here really quickly, minus 7,500. And 46,571. So 46,571.76. So my apologies. Easy peasy. Now back to this. Okay, so in 5 years, Emma's going to need this money to pay for a new phone. Emma, I'm going to suggest that that's not a good investment strategy. Nevertheless, she can earn 8% per annum compounded annually. How much must she invest now to end up with $7,000 in 5 years. So let's think about this. If we think about a timeline, I'm just going to call this year 0. And over here is 7 years out. 1, 2, 3, 4, 5, 6, 7. So she needs to end up with 7 grand, right? That's what she has to have at the end. But it grows when she leaves it there. So obviously the number that we're going to have to put into the bank is going to be less than $7,000, right? So maybe she put, 5,000. This isn't right, but 5,000. And then we're going to add the interest. And then on all of that, we're going to add more interest, right? And so on and so on and so on and so on and so on. And at some juncture, it's going to be $7,000. Now, the 5,000, I'm sure that's probably too low. Maybe it's too high. I don't even know. But you can envision that if she has to end up with 7,000 later on, she has to invest less now because she's going to earn some interest. Okay, so we're going to use that same formula. Maybe I'm going to go with the other one. It's going to be that FV equals PV bracket 1 plus I to the n. Now, this is the same formula, but I think it's a little bit more telling with these variables. So I'm going to write these out. FV, PV, I, and n. Okay, so let's look at this. It says in 5 years, Emma is going to need that $7,000. So that's not how much is in the bank to begin with. That's how much we have to end up with. So that 7,000 is the future value that Emma is shooting for. What we're looking for is how much money in the now that she needs to put away. The principal or the present value. We're going to fill in the other pieces. It says 8% per annum and then compounded annually. Annually means once a year. So in theory, I would do 8% and then I would divide it by 1 because there's one compounding period per year, but that's silly. And then divided by 100 because I have to turn it into a decimal. So 0.08, okay? And then n is the total number of compounding periods. So we're only going to invest for 5 years, which is not very long, right? So this is going to be 5. And whatever number I multiply or I divide by here, I have to multiply by here. So 5 times 1, which is, of course, just 5. Okay, so not a lot different, right? But what we're going to do is we're going to come back here and we're going to say, all right, FV, I know it is 7,000. PV is what I'm looking for. And then it's going to be 1 plus I, so 1.08. 1.08. And then n, well, n is 5. Okay, so lovely. Look what we've got here. This looks different, right? Other times we've been looking for this and we knew this. So we could just take and we could multiply this all into our calculator. Boom, Bob's your uncle and you're done. I can't do that now. So we have to kind of think about BEDMAS backwards. Now, I could evaluate this on my calculator, right? And I'm gonna do that just to show you. It's not going to be a very nice number, right? So I could take and I could do the 1.08 to the exponent 5, right? Not a nice number, not in the least a nice number, okay? But in theory, if you were not proficient with your calculator, you could take that and you could say, so I'm going to do a dual solution here. I'm going to say this is the, meh way of doing it, and this is the good way of doing it, right? Meh, my daughter's favorite word these days. So we could say 7,000 is equal to PV, and then I'm going to grab this calculator, so 1.469. And if you're going to do it this way, you'd want to keep as many decimal places of accuracy as you could. Now, I want to get PV by itself. What's going on with PV? Well, PV is currently being multiplied by 1.469. So the opposite of that is going to be division by 1.469. So divide by 1.469. 1.469. Those are going to go away. And we're going to get, so I'm going to grab my calculator again. Now, if you're good with, your calculator, I know I could do 7,000 divided by, and I could go second function answer and get all of those decimal places. And that's really what you'd want to do. But I'm just going to show what we would get if I didn't do that. So 1 divided by 1.469. And what do we get? We're going to get $4,765.15. So 4765.15. So I wasn't way off when I said $5,000. Okay, so that is how much money Emma would need to put away if we did it the meh way. Let's do it the good way. So I'm going to rewrite this line. So I've got 7,000 equals PV bracket 1.08 to the fifth. Now, this is not a nice number. So what I'm going to do is I'm going to leave it like that. 1.08 to the exponent 5 divided by 1.08 to the exponent 5. Going to go away, It divides out to be 1. And I'm left with PV equals. And now, again, it depends on the calculator you've got, but the reality is you should be able to type these questions in without losing any decimal places of accuracy. This is going to be 7,000 divided by 1.08 to the exponent 5. Okay, and what we get is, so, not a big difference, but, more than $1 difference, right? Like there's $1.07 different between these two. And I kept 3 decimal places of accuracy down here, right? So this is the actual answer. And that's what I would like you to aim for. So 4764.08. So 4764.08. And that is the answer that would make us happy. This one is sort of ambivalent. It's like, yeah, okay, most of the way there. But what we should really shoot for is we should shoot for having all of the decimal places of accuracy, because this is money we're talking about here. And, $1.07 might not seem like that big a difference, but you can imagine that, you do that enough times or with big enough sums of money, and all of a sudden those rounding errors become substantial. Okay, so I'm going to do another question like this that I'd like you to pause and try on your own. So I am, how old am I? I'm 45. Wait. Yes, I'm 45. So I am 45. When I retire at age 65, I would like to buy a new pair of Crocs. So, retirement Crocs, that's where it's at. I got to get myself some retirement Crocs. New pair of Crocs, which cost, I'm going to estimate at the time, $100. Okay. So when I retire at 65, I want to buy a new pair of Crocs, which cost $100. I can earn, how much can I earn? I can earn 9% compounded. So it's 9% per annum, compounded semi-annually. How much must I invest right now to ensure I can afford new Crocs? Okay, so go ahead, pause this, although I'm going to, before you go, semi-annually, just in case you don't know what that means. Semi-annually means 2 times per year. That's what semi-annually means, okay? So go ahead, pause this, see if you can figure out how much money I need to put away right now in order to end up with $100 when I retire to buy some Crocs, okay? Welcome back. So I'm gonna go with the A equals P bracket 1 plus I to the exponent N. And I'm gonna write out the variables A, P, I, not that I, other I, and N. So A is the final amount, right? Well, the final amount is $100. So this is going to be 100. P is the principal or the present value. It's the lump sum that you put away at the beginning. That's what I'm looking for. I is the interest per compounding period as a decimal. So there's my 9% per annum. I'm going to take that 9, but it's compounded twice per year. So I need to divide it by 2, which would be 4.5. But then I need to divide it by 100 to turn it into a decimal. So that's going to be 0.045. And then n, well, I didn't explicitly say the n, but I'm currently 45. I'm going to retire at 65. So that's a difference of, the math is pretty easy there, 20 years. Goodness, 20 more years of teaching. All right, so 20 years, but it's compounded more than once per year. It's compounded twice per year, so I'm going to multiply by 2. Again, this is always going to match this. So that is 40. Now, we go back here, we substitute stuff in. A is 100 equals principal, don't know it, 1 plus I. So that's going to be 1.045 to the exponent n. Well, to the exponent n is, of course, to the exponent 40. Now, I want to get the p all by itself. I'm going to do it the right way. I'm going to divide by 1.045 to the 40th. I'm going to divide by 1.045 to the 40th. Going to go away, going to go away. And I'm going to grab my calculator. Okay, and so we're going to type that in. So we've got 100, turn on you, 100 divided by 1.045 to the exponent 40. So I need to put away $17.19. Okay, so $17.19 must be put away in order for me to get those swanky yellow retirement Crocs. And they'll still be yellow when I retire. Or I hope they're still making yellow. Oh my goodness, I would be so. Maybe I should go and buy some more just to put them away to make sure I've got them later on. Probably should. Okay, so there you go. So there's another example of figuring out. It's called figuring out the present value of something. It's like, how much is it worth in the future versus how much is it worth now? Present value is now. Okay, so there's another variant that we can do when we use, there's another 2 variants, but one of them's kind of silly and I'm not going to worry about it. But here we go. So we have this a equals p bracket 1 plus I to the exponent n. We're pretty good at solving for p. We've just done a couple of examples of that. Solving for a is cake. That's the one we did last week, and you just plug it all in and you hit enter and away it goes. In theory, we can solve for both I and for n. The solving for n, it's kind of beyond, like, it's on our curriculum, but it's silly because it just requires trial and error. So I'm not going to worry so much about that. It requires trial and error in this grade. You learn how to do it the right way in advanced functions in grade 12, right? So you're not going to have exposure to that. But we can definitely solve for I. So let's look at what we're going to do. So let's do an example question of what we would look for I. So Ernie invests $15,000 for, let's say, 10 years. And ends up with, I don't know, how about 30,000? He received annual compounding on his interest, but he doesn't remember what the rate was. Solve for the rate. Okay, this is definitely harder, okay, but it's not beyond us. So we're going to start out the same way as we have with all the other ones. We're going to start out with listing out the variables, A, P, I, and N. A is the final amount. Well, we've actually got it. It's 30,000. Right? So we end up with 30 grand. P is the starting amount. It's the principal that we put away. It's 15,000. I, don't know it. N, 10 years. And we have to be careful. It's the number of compounding periods in total. So it's 10 years times however many compounding periods there are. But it says that he received annual compounding, which means it's just once per year. So just one, right? So N is just 10. Okay, we're going to take and we're going to plunk these things in. So 30,000 is equal to 15,000. And we're going to have 1 plus I, because we don't know what I is, to the exponent, in this case, 10. All right, so there we go. This is way different than what we've seen so far. Don't have a lot of room, but that's good. We can still solve here. So I'm going to have to get to the I, right? And so I'm going to think about BEDMAS backwards, or my good friend Sam Deb. Right? So some of you already know how to go through this and solve it. Some of you don't. Stuff inside brackets, I don't have access to. It's kind of like one unique thing. I can't play with that yet because it's inside brackets. So I say, is there any addition or subtraction that I have access to? Well, there's not really, because even though there's addition in here, it's inside brackets, so I don't have access to it. Is there any multiplication or division I have access to? Yeah, there is. This 15,000 is multiplying the thing we want to get at. So the first thing I'm going to do is divide by 15,000. So divide by 15,000. Divide by 15,000. Right? Those are going to go away. 30,000 divided by 15,000 is 2. I did that on purpose for nice numbers. So then we've got 1 plus I to the exponent 10. Here's where we're going to kind of venture off on a pathway that you might not have played with before. If this was squared, so imagine we had a different problem. So here's an aside. So an aside example. And certainly you don't need to write this down. An aside example. Oh, whatever. You know it's supposed to be underlined. If I had 20 was equal to x squared, what operation would I do to solve for x? Well, you know you would square root, right? You would square root. If I had x cubed equals 32, what operation would you get to the x? Well, you would hopefully know you would cube root. Should have done that in grade 9. Okay. What we have here is we have x to the 10th is equal to 2. It's not x, but it's like x. It's a variable. So I need to take the 10th root of both of those sides. And those are going to go away. We're going to end up with x equals whatever the 10th root of 2 is. Now, each calculator is somewhat different. Some of your calculators, hopefully most of your calculators, will have a button that looks like this. It's a square root button, but it's got a little itty bitty x out in front with potentially might have a y inside. But it's the x in front of the root symbol that we're looking for. Okay, that's what most of them have. There might be one or two of you out there that have a button that looks like this. Y equals, or sorry, it has y to the exponent 1 over x. Okay, not very many calculators have that. Some of them do. Most of them are going to have that button right there. Okay, so how we would use that is we know, hopefully we know now, I'm going to need to take the 10th root of this. So I would write it like that. There's the 10th root and there's the 10th root. On this side, the 10th root of something to the 10th is just the something. So that's all I've got there. But I need to do the 10th root of 2. So depending on your calculator, and you're going to have to play with your own calculator, most of them you would type 10 and then this button and then 2 and press equals. And it's going to give us the result. And I'm going to show you what the result is in a moment. So on my big fancy calculator here, that's actually, where is my mouse gone? There it is. It's actually kind of hidden. So I'm going to do 10 because I want the 10th, and I have to drill into the math menu. And there's my version of it, the X root button. So go down to the X root button. So the 10th root of 2. And I'm going to get 1.0718. 1.0718. So where are we at? 1.0718 is what that's equal to. Now, hopefully you can play around with your own calculator and do the 10th root of 2 and get this. I'm going to show you one more way that we can do this that doesn't require you to have an xth root on your calculator. And in fact, on my own, I would never really use this. The other way that we can do the 10th root is, remember we talked about the caret rule, right? The caret rule for exponents says that there's the power on top and there's a root on the bottom. So if I want the 10th root of this number, I can do 2 to the exponent 1 over 10. And it's going to give me the same thing. And I'm going to demonstrate that. So if you have a calculator with brackets, it's pretty easy to do this. So I can say 2 to the exponent of bracket 1 divided by 10. And we're going to hit equals. And there it is. It's the exact same answer. And that sort of explains why some calculators have this button. Because if I want the 10th root, it says, oh, I'm going to do it to the fraction of 1 over that number, the 10th. So you need to play with your own calculator to get it to a point where you can actually do that, right? So I'm not quite done yet. We're most of the way there. Now, I want to get I. So I'm going to say, what's happening now? I'm adding 1. I'm going to bop that 1 to the other side. It's going to become negative. So we're going to have 1.0718, minus 1 equals I. So that means that I is equal to 0.0718, which is lovely. That is the answer, but that's the answer as a decimal. And when we're talking about interest rates, we like it to be in a percentage. So to convert a decimal to a percentage, what do? Hopefully you're all shouting, multiply by 100. So we would say, therefore, the interest rate was 7.18%. Okay, there it is. Right, so that's pretty heavy duty. That's pretty good. But it's definitely something that you should know how to do and you have the capacity of doing. Okay, so I'm going to stop the video there. I'm going to write up a couple more examples for you to practice that I will post with this lesson. Okay, thanks everybody. Have a great day.